All right, good morning. It is that time yet again to bring your A game of focusing. Get ready for the Test 17 review. Let's kick it off with one coming at us from lesson 22 and 42, divisibility rules. And this question is going to say, each of these numbers divides into 320 without a remainder except. And you could set up 320 in a divide box and try to divide each one of these out. But there's a whole lot easier way if you remember. If it will divide by 5, if it ends in 5 or 0. 320 ends in 0, so I know it can't be B. It'll divide by 10 if it ends in 0, so I know it can't be A. It'll divide by 2 if it's even, so I know it can't be C. The divisibility rule for dividing by 3 is add the digits, and if the sum is divided evenly by 3, then it can. Well, 3 plus 2 plus 0 is 5. You can't divide 3 evenly into 5, so your answer would have to be D, right? Let's check out this one. Angle DAB is acute. We're talking the angle from D to A over to B. That's a cute little angle, right? So they want to know which angle is obtuse. Make sure you remember these words. Obtuse is more than a right angle, more than 90 degrees. Acute is less than a right angle. So where is your acute angle? It is from A to D over to C, right? Now the trickiest part about this is actually remembering how to write your angles. And you can't just put down 3 letters. You either got to write the word angle or write it with an angle abbreviation. So 3 capital letters and the angle symbol. Angle, A, D, C is my obtuse angle. Which segment is perpendicular to segment DC? Well, first of all, let's take a look at what we're talking about. Segment DC is right there, right? And they want to know which is perpendicular. Make sure you get these words straight. Perpendicular means it intersects and forms a right angle. So 2 different segments here are intersecting with segment DC. The one that's forming the right angle is right here. So it's segment CB. Just like with angles, make sure you can't just put down letters. It would be capital C, capital B, and you either better write the word segment in front of it or give it the segment abbreviation on top of it. What is the name of this shape? If you take a look at it, we usually serve it up with ice cream. If you're not sure, because I guarantee it's not going to be this shape on the test, you can always turn to our handy dandy chart in lesson 83, right? But in this case, this is called a cone. Take a look at this one coming at us from lesson 46. What number is 1/4 of 40? And we've been saying this for months and months now. If the numerator is 1, divide by the denominator. So the denominator of 1/4 is 4. What is 40 divided by 4? Well, that's going to give us 10, right? And then it says, what number is 3/4 of 40? Remember, of means multiply. Write 40 with the denominator of 1, or if you can remember how to visualize it, if 1/4 is 10, 3/4 would have to be 30, right? Okay, one coming at us from lesson 82. Find the greatest common factor, the GCF, of 24 and 32. So let's start off listing factors. Always start off with the easy one. We got 1 times 24. Hey, it's even, so I know I got to use 2. 2 times 12. 2 plus 4 equals 6, so that means 3 would have to be a factor. 3 times 8. And let's not forget our last one. We have 4 times 6. Those are factors of 24, right? Let's go ahead and do it all over again for 32. We have 1 times 32. It's even if it's not on a multiplication chart. You know 2 is going to be a factor. 2 times 16. 3 plus 2 equals 5, so I know 3 can't be a factor. And we know 4 is going to be a factor with 4 times 8, right? So now that we have all of our factors listed out, let's take a look at what one is the greatest common factor, in which case it's going to be 8, the biggest number that's a factor of both, right? So then it's going to ask us to use the greatest common factor of 24 and 32 to reduce 24 32. So we said the greatest common factor is 8. So I'm going to divide the numerator by 8 as well as the denominator of 8, right? Then I just have to go numerator divided by numerator. 24 divided by 8, hey, that's 3. And denominator divided by denominator. 32 divided by 8, that is 4. Reduces down to 3/4 in its lowest terms. Check out this one. How many quarts are in 2 gallons? And if you turn over lesson 85, units of capacity, think quarts, that there are 4 quarts in 1 gallon. Quarts is the root of quarters. Think there are 4 quarters in $1, right? 4 quarts in 1 gallon. But I need to know how many quarts are in 2 gallons. So what's 4 times 2? That would be 8. One coming at us from lesson 78, talking about exponents. I will tell you right now, the answer here is not 12. The base is the number you're multiplying. 4 is the number you're multiplying. The exponent is how many times we're multiplying it. This does not mean 4 times 3. This means 4 times 4 times 4. We're taking 4 and multiplying it out 3 times, right? And you can't multiply 3 numbers together all at once. You have to multiply 2 of them, get a product. 4 times 4 is 16. And then go and multiply that by the next number. 16 times 4 is going to give us 64. Do not multiply the base and the exponent together, please. Here we have to go and reduce each fraction. Remember, we want to strive for finding the greatest common factor, but if you make a mistake, just make sure that it's in the lowest terms, and if it's not, divide the fraction again. So let's start off here, 14/28. I'm going to start off with the common mistake kids will make, and they'll think they're going to divide by 7. And 7 is a common factor. But watch what happens. 14 divided by 7, hey, that's 2. 28 divided by 7 is 4. The biggest warning signal at all. You will never leave a fraction with a pair of even numbers and consider that lowest terms. Once we're down at 2/4, almost everybody knows 2/4, Mr. Hines. Hey, that's equal to a half, right? I actually have to divide it by 2 one more time. And 2 divided by 2 is 1. 4 divided by 2 is 2, because honestly, if I only wanted to divide it once, 14 would have been my greatest common factor, right? Let's try another one down here. I will pick the greatest common factor for real this time, which is going to be 9. I'm going to divide the numerator of 18 by 9, the denominator of 27 by 9. Numerator divided by numerator. 18 divided by 9, that's going to give us 2. 27 divided by 9, that's going to give us 3. So you always want to strive to find the greatest common factor, but if you make a mistake, just keep dividing. Here we have to go and compare, and I was kind of amazed how many people struggled with this one on the last test. So if you don't catch it right now, multiply it out. 2 times 3, that's 6. 3 times 3, that's 9. Take a look at the other side. 2 times 5, that's 10. Denominator times denominator, 3 times 5, that is 15. Feel free to go ahead and use cross multiply, and if you don't know, 9 times 10, that's going to be 90, right? 15 times 6, that is also 90. So 90 compared to 90, that means these guys are equal. But I want to point something out here. 3/3, that is a fraction equal to 1, isn't it? And over here, this 5/5, that's also a fraction equal to 1. Anytime you multiply a fraction by 1, it's not going to change the value. So you're really comparing 2/3 compared to 2/3, right? Because we have the identity property of multiplication. But if you don't catch it, feel free to multiply it out and use cross multiply. 560 times 704. I cannot stress enough on the test. Set this up on a scratch piece of paper. 99% of the problems I see on these guys is people trying to cram it into a little itty bitty workspace and writing too sloppy and making silly mistakes. Let's go ahead and start multiplying. Once I have everything lined up nice, neat, straight, with enough room, then I can go and add. 0 plus 0 plus 0, hey, that's 0. 4 plus 0 plus 0, that's going to give us 4. 2 plus 0 plus 0, that's 2. 2 plus 0 plus 2, that's another 4. Nothing plus 9, hey, that's 9. And nothing plus 3 is 3. So I have 394,240. Again, giving yourself enough space and keeping everything neat and straight and lined up is the secret to this success. Here we have 3 2/3 plus another 3 2/3. And you don't want to leave an improper fraction. Let's go ahead and do the fraction side first. 2/3 plus 2/3, that's 4/3. 3 plus 3 for the whole number side, that's 6. But you can't leave an answer of 6 4/3. We got to take care of this improper fraction. 3 divides into 4 one whole time, right? Multiplies back for 3 and subtracts for 1. 4/3 is really 1 1/3. But that's not the answer either, because we had a whole number answer of 6. So now we have to go and add these two together. 6 plus 1 1/3, that's going to give us 7 1/3. 4 minus 2/3 plus 1. Remember, do the work in parentheses first, but don't forget to do the rest. I saw some people on the last test think that this is the final answer right here. 2/3 plus 1, well, that's easy enough. 1 2/3, right? But don't forget to take a look at the rest of the problem. Now it says 4 minus 1 2/3. I actually better be serious and set this one up vertically. 4 minus 1 2/3, because kids who try to do these in their head is where the silly mistakes come from. So I'm going to start over here. Nothing minus 2/3. It is not 2/3. It is a borrowing problem. I have to borrow from this 4. 4 becomes 3, and I'm going to write 1 whole on the fraction side, and I'm going to want to use a denominator of 3. So how many thirds makes up 1 whole? 3/3. 3/3 minus 2/3, that is 1/3. 3 minus 1, that is 2, for a grand total of 2 1/3. What is the area of this square? Remember, area is length times width. And because this is a square, all 4 sides are the same. So if the width is 3, this length is 3. So I'm going to have to go 3 times 3, length times width, and that's going to give me 9. But what type of centimeters? Because it's area, I have to label it as 9 square centimeters, right? And that is the end. I can't say it enough times. Go slow, go careful, double check your questions and your answers. Good luck.